Okay, in today's tutorial we're going to show a way where we can get some designs for these styles of lamps. This is under the category of like the Japanese style lanterns, and this are the variety that are laser cut. So they're obviously more square, made out of a thin piece of plywood, which is a perfect use of the laser cutter machine. They don't have to be square, they can also be, as in this model over here, this is with a hexagon. You could completely model this yourself if you knew all the maths. You could do it all with Illustrator or any SVG compatible software. For this tutorial, I'm going to be doing it on Adobe Illustrator, but I'm also going to find a free version. Inkscape is a free software that does a lot of things very similar to Adobe Illustrator. So give me some time to learn how to do that, and eventually I'll make a tutorial for Inkscape. What I want to do is the actual making of this lamp. I want to simplify that for you by showing you this website called Boxes.py. PY standing for Python. Boxes.py is an open source, which means it's free. And I believe the story of this website, there was like a hackathon where people had like 24 hours to make like a website that could do something cool, and they decided to make a website where if you put in some numbers or you put in some values, they'll input the SVG file, which can then go to the laser cutter. Do you remember when you did the laser cut clock in year 7? How you'd make a file on Illustrator, and when you made it like red, it would cut all the stuff out, and then you'd send that to the laser cutter machine and you get the components out? Well, this website gets that file when you put in the information. For example, and as we see here, we scroll through, there's a bunch of different types of boxes. These are clearly all done by cutting pieces of plywood, but it could also be used for acrylic or any material that can be laser cut. Over here, we even use living hinges. So if you cut plywood in a particular pattern, it can actually be flexible. So you can actually get it to curve around. There's also things like, they have more custom designs here. We will focus on the very top ones for now. We're going to start with just the box, the humble A box over here. And when we click A box, we'll load up to a website, and over here we're putting in the A box settings. If we put the X, Y, and the height of the box, it's going to give us what each of the panels are going to look like to make that box. So let's say my lamp, I want it to be 75 millimeters by 75 millimeters. These are all in millimeters, yes. And I want my height to be, what's a good height for my lamp? 20? 20. I want my lamp to be 20, which is 200 millimeters. Now over here, this is outside, so this is the outside dimension. So when they were doing their coding, they even included, if your piece of wood is 3 millimeters thick, that's going to change all the cuts. So we want the outside, we want it to be this big. The bottom end, we'll keep this, we'll just not change any other settings for now. Thickness of our timber is 3 millimeters. We'll do nothing else, and we'll just see what happens when we press generate. So press generate, and boom, here we go. Here is all the pieces of the wood would have to cut out to make the box. So it already had, and see how it has all these, it already has all the teeth perfectly cut. And if we zoom in, oh, I can't do anymore. But if we look over here in the corner, see how it's not exactly straight? It even goes so much to make the laser cutter go beyond there and start a new cut. So you have a very clean corner instead of just going, just doing a right angle, which will mean the edge would still be slightly curved. So it goes beyond that, and it does all those calculations. One issue is this is black and this is blue, and they've even got a reference piece in here for when we want to open this up into a software. We can make sure that this member over here is 10 centimeters, because if it's not 10 centimeters, then that means all our scale is going to be off. The scale has to be precise because this thickness of these blue members down here, that's 3 millimeters thick, those blue members. If we got the scale wrong, it's going to be too thin to fit our wood. So I believe we can right click and we can save as, we can A box 1, right? A box 1. And then if I can then go to Adobe Illustrator and I can go File and I can go Place, and this is all stuff that you obviously remember from year 7. Press A box 1. The one thing I want to do is show import options. Place this file somewhere, and here we see, I have my pieces ready to be laser cut. I can then, because it is Illustrator, I can of course edit and move my pieces around. So this one will be here, and to fit them all on the printer bed. Part of this in your design, if you have any design criteria that relates to being efficient with material or reducing your waste, one of your design criterias you can include is when you are making these members on the cutting board, you can say, the amount of waste material, right? If we do a piece here, there's only this area over here that's wasted. And you can do that as a math thing. If you want, you can say percentage-wise, it's like 10%. So out of a whole sheet of timber, you're only wasting like 10% of the wood. That's a value you can use if one of your criteria was to be efficient with material. We have this here, and then this can't be cut. Do we remember what color is the cutting color for Adobe Illustrator or our laser cutter? Red, yes, very good. Do you remember what other criteria there was for it? So it had to be red. It had to be a specific type of red. It has to be RGB red. So when we made a new document, over here we had to make sure this over here is set to RGB. If it is the other option, which is CMYK, any photography students, you know what CMYK is? Cyan, yeah? Cyan, something, yes, cyan, magenta, yellow, and black. So those are your 4 colors that your printer uses. So Illustrator uses cyan, magenta, yellow, black. If you're doing a poster, those are the colors that the printing presses are going to use. So you can send that to the printing company. They know exactly how to use those numbers. While RGB is the numbers that gamers use, but also computers and now laser cutter uses RGB. So we need to make sure it's in RGB. Cancel. We can change that by changing the color over here, where's the stroke. We can click it, and if we hover over, it should say RGB red. Yes, the other criteria, do you remember that it had to be a certain thickness? Does anybody remember what the thickness of it was? 4 years ago. Anybody? Was it thick or thin? No. 0.0001. And I think what I'll also do is I'll give you the document. Do you remember how you went through a PowerPoint presentation in year 7? I'll give you that document again. So there's some pages at the end that show stuff it's specifically related to 3D printing, laser cutting, and you can refer to that. It's got like settings that you might need to know. But so now I've recolored it, and it's sort of red and difficult to see. But can you see on the projector how it's red? Right? So now this would cut out of the laser cutter, and I could assemble this into my box. In fact, I have Fusion open as well, and one of your criteria is to do rendered drawings, right? Well, you don't know yet because I haven't given you the assessment task. One of your criteria is rendered drawings. And you can insert over here, we can insert SVG file, the SVG that we just had, insert from computer. We can do that A box. So over here, oh no, did it freeze? All right, so now we have, see over here we have this, we have the SVGs imported into Fusion 360. I can turn these into 3D objects because these are sketches. And of course, as we remember from Fusion, what does it mean when a sketch has a blue interior? It means we can turn it into a 3D object. So if we go extrude, 1, 2, 3, 4, 5, we can press those 5 shapes. We can, so if I want to turn these 2D shapes into a 3D shape, how thick should they be? How thick is our wood? 3 millimeters was the example that we gave the website. And if you are buying the wood from Bunnings to make your tower out of plywood, 3 mil is the plywood you need. Press OK. So now, over here we have, these are now bodies in Fusion 360, and we can actually, these are chunky boys. Let me undo this. I think there is, when we imported it, let me measure something. Okay, so that is not the size we need. So 26, and this is why when we import into Fusion, we get this reference line. This line should be 100 millimeters. In our example, it's only 26.459. So we're going to have to scale our drawing to be larger. And we can do that. We can edit the sketch. Edit sketch. We can modify sketch scale. We can select everything. And the point we want, we can just say this point over here. Now, if our original one was 26.456, I think. If we do 100 divided by that, if this works, everything should be larger. All right, so as we're going to have to re-import the sketch. We'll import it, insert, SVG, find it, A-box1, and over here we're going to have to change this scale. So instead of 1, it's going to be 100 divided by 26.465, and now this length should be 100. Close enough. 99.97. Okay, cool. So now we can go and we can extrude it. We can finish this sketch. If we extrude it, so now if we look at these things over here, these look like what our sheets of plywood will look like, and we can start building the lamp on Fusion 360. So we can click and move objects. So first, let's say I want to move this piece like that, and then I can use the align tool. Where is the align tool? The align tool, I can start aligning up this face with maybe that's not the best. Maybe the best alignment is to go let's try aligning. All right, we have this. So what I'm doing here is when we're aligning it, is we have to pick 2 points or 2 things that we want to overlap. So in this case, I'm trying to get this center, this line over here should be aligning with this line over here. And then we're just repeating that throughout the rest of the tower. So again, we go to modify, align, and if sometimes it's on the wrong side, as in see this one over here, if we move it, we see it's on the wrong side where we aligned it. You can do stuff like flip over here. But angle and flipping it, there you go. And now we just have the last piece, and then we can see that our lamp is being built in Fusion, and we did not have to draw all of these individual components for our lamp. Right, so now at this point you have your lamp somewhat built, although this one is not transparent. So what we can do on Fusion is we can go through and we can do a sketch and we can press anywhere we want. And if you prefer to do these designs on Fusion or on Illustrator, I'll show you first the Fusion method and then the Illustrator method. So we can do some things. We can obviously do our Fusion thing where we can draw some lines in any direction we want. Yeah, what animal did I draw? A dinosaur? So I drew that sketch, then I can go over here, I can go press extrude, and if we go backwards, we cut it out. It's clearly a duck, right? It's clearly a duck, thank you, thank you. And then we can also do other things, we can do patterns, so if we'll sketch on this wall over here. As we're sketching over here, we can of course do, right, if we like this circle, then we can go create, we can do a rectangular pattern where we can press that circle and then we can make something like that. And then we can extrude, we can click and we can cut these holes out. We also inserted the pattern of this through SVG, so we can also insert other patterns. So I, for example, went to Google, looked at patterns.svg. A lot of these websites are dodgy. They'll say it's free, but they actually want you to put in a credit card and then they'll give it to you for free. Don't do those, please. Also, a lot of websites, when they have the image, if you try to just get the image search, it's not the SVG file. It's a bitmap file. We need it to be SVG. SVG is like the line software that Fusion and Adobe Illustrator works. This particular model over here, well, when I did that, it loaded up this screen over here, this trippy looking screen. Looks like a bunch of Wi-Fi logos. And then if you look at the top here, it actually had a file name of .svg, so I was able to right click it, save image. When I did that, I can then import that image because if I go over here, insert SVG. Now this one I labeled it previously as wave.svg. Open. And this one, I can say I want to place it on here. How big is it? Oh, it's huge. So I have this shape over here, and let's say I want to put some of these. I think the easiest way for me to do this is to extrude. I'll have these. I'll move and copy these over here. So now I have these over here. Okay, I can also if I press Shift, I can select all of these bodies. And now that I've selected all these bodies, I can actually remove it. Shh. Too loud. I can use the combine tool to actually, instead of combining it, I can use the cut tool. And if I press OK, now the body should have, hold on. I'll have to put them inside first. So we're going to press the move button. We'll move them backwards so they're inside. Okay. And now we'll do the combine tool again. And if we press cut, these should be almost. That's fine. When we did this move, I can fix it. Edit feature. There we go. Okay. There we go. So now we have the holes over here. Now, when you want to get from this back to the laser cutter, Fusion actually lets you get these files straight into the laser cutter. So this lamp, if I wanted to make, and next lesson I'm going to show you how we can render these. We have a double lesson next lesson, so I'm going to give you the assessment task, and I'll show you how we can get some rendered drawings out. So the important one over here is probably this little one over here. This looks like the nicest one. And I'll show you an example of one. Once we've done it with one, we can do it with all of them. So Fusion, you can if you press Create Sketch, and you press, see as I hover over this shape over here, do you see how it's all highlighted in white, except the holes? So if I click that shape, let it load up the sketch, and then finish that sketch, don't do anything. If I go to the sketches over here, right, that sketch exists, and if I actually hide all the bodies, we can see over here, the sketch, can you see it's got the dark blue lines in the middle? So it's actually got the thing. So what we can do then, we can right click that sketch, save it as a DXF, and DXF is another file that Illustrator can understand. So we'll just call this, well, this won't be CO2 drag cars. This will be stage 5 engineering. 2020. Sorry, we got this file over here. So now if I go to Adobe Illustrator, and if I go File, Place this DXF file, you see here we have the lamp file, and the drawings that we made in Fusion are already in there. So now we can do the same thing we did previously. We can make it red, and we can start cutting those holes out. And yeah, DXS are going to come in as black, but again, we can change that color, change the thinness, and then you can cut this out. And then your frame of your lamp is basically done at that point. You get to spend more time in designing the artwork. You can also choose to do the artwork in Illustrator or later in Inkscape if you want. There's also ways in Illustrator and Inkscape where you can get a bitmap image, which is not a vector, and you can use image trace and it can turn it into a like a vectored image. You can also do the same thing with a logo. Just consider if you're laser cutting a lamp, you want it to be like a stencil, because if there's like an object in the middle, it's not going to be held up by anything. I did have one student last year, as a bit of an idea, that had their lamp, and when they had their lamp, these things over here, they glued that on. So if you get, that's like baking paper you can use, or tissue paper. You can glue something onto that if you want. You just got to be careful. So we can do that. All right, that's the end of this tutorial. Next time we'll enhance Fusion and we'll get some rendered drawings out.